What is going on, guys? My name is Amos and I'm back with yet another video. So in today's video, I'm going to be doing 6 integration problems with you guys. Now I have a lot of work to do, so let's get started. So let's look at the first problem. All right. So we want to solve the integral, that is x squared divided by 1 plus x squared. All right, so that is the first, no, not x squared, but x to the power 3. So we have x squared over 1 plus x to the power of 3. So find the integral of the function x squared divided by 1 plus x to the power of 3 with respect to x, dx. So to solve this problem, there's actually something you guys have to know. Whenever you have the integral of, let's say, a function u, now you have its derivative u prime and divided by the actual function u. And if you are integrating with respect to u, whenever you have such, this always evaluates to the natural log of u plus the constant of integration. All right, so that's what we want to do to this problem. We want it to look like this one here. So the integral, this evaluates to natural log of u. Now the u has to be in absolute values. So natural log of u plus the constant of integration whenever we have such. So now let's look at the derivative of the denominator. So the denominator is 1 plus x to the power 3. So what is the derivative of 1 plus x to the power 3? Notice that the derivative of this guy, the derivative of 1 is 0. Now, right, the derivative of 1 is 0. The derivative of x to the power 3 is 3x squared, right? Now, at the top here, notice that we are missing a 3 for us to have this form, u prime over u. So what are we going to do if we are missing the 3? So we're going to do this. I'm going to add that 3 here so that it becomes 3x squared. Now, 1 plus x to the power 3, and then dx. And then I'm going to multiply by 1 over 3 so that the integral does not change. So we multiply by 1 over 3 and add our 3 there. Now we have it in the form u prime over u. Therefore, this integral is going to be 1 over 3 natural log over 1 plus x to the power 3 in absolute values plus c. So that is your integral. Now we move to the second problem. We are done with this one. So I'm just going to erase this part. All right, now number 2. So we have the integral of the function 1 over 2x plus 1 to the power of 3. Now we are integrating this with respect to x again. Another way of seeing this function is this integral is equal to, that is 2x plus 1 to the power minus 3 dx. Now whenever we have something that is linear in x raised to a certain power, that is 3 raised to a certain power 1, and we want to find the integral of that function, what we simply do is, let me just give you an example. Whenever we have this ax plus b raised to a certain power, let's say n. So whenever this thing that is inside the brackets, whenever the function that is inside the brackets is linear in x, that is, we don't have any x to the power 2 and any x to the power 3, well, finding the integral of such a function is actually very easy. So you're going to say it's going to be ax plus b. Now you're going to add 1 to the current power, and then you're going to divide by the new power multiplied by the coefficient of x. In this case, the coefficient of x is a. So we multiply by a. Now this is going to be the value of this integral. This is what the integral is going to evaluate to. So this is our case. So for our case, we have n is equal to minus 3, and the coefficient of x in this case is 2. All right. So this integral is going to be equal to, now remember, it is 2x plus 1. If I add 1 to the current power of 2x plus 1, I'm going to have minus 2. So we're going to divide by minus 2 multiplied by the coefficient of x, which is 2. So this Now this is going to be equal to, now this is like minus 1 over 4 multiplied by, now it is 1 over 2x plus 1 to the power 2. Now this is going to be minus 1 over 4. No, it's going to be, now I'm going to multiply at the denominator, and then I'm going to multiply 4 and 2x plus 1 and 1 and 1. So I'm going to have minus 1 divided by 4 and then 2x plus 1 to the power of 2. Now we are done with this problem, so we move to the next one. Great. Number 3. So we have the integral of 1 over x multiplied by natural log of x dx. Again, remember that whenever we have the integral of u prime over u, where u is our function that depends on u, and that depends on u in this case because we're going to integrate with respect to u. So whenever we have such, this always evaluates to natural log of u plus the constant of integration. Now we need to look at this, the function that we're given, the integral of this function, we need to convert it into that form. Now I can also write this as the integral of 1 over x multiplied by 1 over natural log of x. Great. Now this 1 over x is the derivative of natural log of x. So if you the derivative of natural log of x is 1 over x. Now that's great. So this means that our function is already in the desired form. It is in the form. Now this natural log, this 1 over x is our u prime. And then this 1 over natural log of x, our natural log of x is u, right? So it's already in the desired form, u prime over u. So this is going to evaluate to natural log of u. Now our u is natural log of x. So this has to evaluate to natural log of, that is in the absolute values, natural log of x plus the constant of integration. This means that we are done with this problem. Now we go to the fourth one. The integral of x e to the power x squared d dx. So how do you find the value of this integral? So it's actually very simple. We just have to make a change to this function x multiplied by e to the power x squared. Now what we have here is a function. So e to the power x, we have two functions here. We have e to the power x and x to the power of 2. These are the two functions that are making up the function e to the power x squared. Now whenever we have such, we need to always change some variables. That is, preferably we want to change the x to the power of 2. All right, because we know how to find the integral of e to the power u. We just it's e to the power of u, right? So we want it to be in that form. So we're just going to change the x. We just want to change some variables before we even find the actual value. So let's say let's let t be equal to x to the power of 2. Now dt is going to be equal to 2x. All right, 2x dx. Now if t is equal to x to the power of 2, this means that x is going to be equal to the square root of t. Now here I'm going to substitute. So x is the square root of t, d dx. So this means that dx is going to be equal to dt divided by 2 root of t. All right, so this is what we have. Now we don't have any bounds here, so this integral is going to be equal to this. Now this x that we have here is root of 2, so I'm going to put root of t, so I'm going to put the square root of t. Now we've changed, x squared is t, so I'm going to put t here. What is our dx? Our dx is dt divided by 2 multiplied by the square root of t. Now the square root of t and the square root of t simplify. The half is the constant. The half is a constant, so we take it out of the integral sign. So we have half multiplied by the integral of e to the power of t d dt. So now we have half. Now what is the value of this integral? So it is actually e to the power of t plus, now we need to resubstitute here. We need to go back to our default parameter, which is x. So we have half multiplied by e. Now what is t? T is x to the power of 2. So plus the constant of integration. Now this means that we are done with this problem. So we move to the next problem. All right. So problem number 5. Now the fifth problem is going to be the integral of x squared divided by 1 plus x squared. Now for this one, we just have to be a little clever. All right, we are actually integrating with respect to x. So what we do in such problems is that, look at what we have here. The highest power of x is here, the numerator level. The highest power of x is 2. And we have that the highest power of x at the denominator level is 2. So we have x squared and x squared at the bottom and at the top. So we try to reconstruct our denominator at the numerator level. So I can say that this is going to be equal to the integral of, now, x squared. For us to equal the denominator, we are actually missing a 1. So I'm going to add a 1. But then I have to subtract the same quantity, that is the one that I've added, so that I do not change the value of the integral. All right? So I do not change the integral. I like the definition of the integral, the way it's defined previously. All right? So we have 1 plus x squared. Now, I can actually split this into two integrals. The integral of x squared plus 1 divided by x squared plus 1. Now, we turn it in reverse. Started with x squared and 1. We're going to split it into two integrals minus the integral of 1 over 1 plus x squared. Now, this is dx and dx. Now, look, x to the power 2 plus 1 divided by x to the power 2 plus 1 is dx minus the integral of, now this is a usual primitive. This is a usual primitive. It is actually arctan of x. Now, what is the integral of dx? It is x. So it is x minus arctan of x plus the constant of integration. So we are done with this problem. So you can always think about this this resolution whenever you have the degree of x at the numerator level equaling the degree of x at the denominator level. You try to reconstruct your denominator at the numerator level and try to see if you can split the problem into two integrals. All right, it becomes simpler that way rather than looking at the function the way it is defined before. So here we've actually added 1 and subtracted 1 to make sure that we don't change anything. All right, so I'm just going to take care of this part. Now the sixth problem is actually the last problem. So we have the integral of 1 over 1 plus e to the power of x. Now look at this one. So this one is just like the previous problem. So we have 1 and 1. So we want to find the integral of 1 over 1 plus e to the power of x. So we try to reconstruct the denominator at the numerator level. So what is missing is the e to the power of x. So this is going to be the integral of 1 plus e to the power of x. And then I have to subtract the e to the power of x so that we don't change anything. So we have that. Now 1 plus e to the power of 1 plus e to the power of x. Alright, now I can split this into two integrals. The integral of 1 plus e to the power of x divided by 1 plus e to the power of x minus the integral of e to the power of x and then 1 plus e to the power of x. Now for the first one, now this is dx and that is dx. So this is going to be the integral of dx minus, look at what we have here. The derivative of 1 plus e to the power x is e to the power x. So this is already in the form u prime over u. So this is going to evaluate to natural log of 1 plus natural log of 1 plus e to the power of x. Now I'm not going to put this in absolute values, because we know that for every value of x taken in the set of real numbers, e to the power x is always positive. Now 1 is positive, so adding 1 to something that is already positive will always give us something that is positive. So we don't have to put 1 plus e to the power x in absolute values. Now what is the integral of dx? Well, it's actually x. Now minus natural log of 1 plus e to the power of x plus the constant of integration. Now you might be doubting your resolution. Now you might think that now here we don't have the previous situation where the highest power of x at the numerator level equal the highest power of x at the denominator level. So it's actually the same. It's actually a trick that you can also apply here, though we don't have e to the power x at the bottom and at the top. So you can just add the e to the power x there, and you can actually have your value. All right, so now let's look at our bonus problem. Now this bonus problem is going to help us understand the technique that we used in problem 2. It's going to help us understand when it applies and when it does not. Let's look at this problem. All right, so this is going to be our bonus problem. So let's look at the integral of 1 over 2x plus 1. All right, let's look at this integral. Now here we can also, so dx, we can also visualize it in this way. So it can be 2x plus 1 raised to the power minus 1. Now if you look at the resolution, or the step we took in order to evaluate the integral in problem 2, we actually say that, oh, we have something that is linear. All right, something that is linear in x, a function that is linear in x here. So we have 2x plus 1 raised to the power minus 1. So here our n is equal to minus 1. All right, so we need to add 1 and divide by the new power. Now look at what happens when we add 1. So this is going to be plus 1 minus 1 plus 1 multiplied by the coefficient of 2, which is just 2. So here we get 0. We get 1 over 0. So it will be 2x plus 1 raised to the power of 0, which is 1. Now negative 1 plus 1 is 0, so we get a 1 over 0. So this is undefined. All right, so we run into a problem when n is equal, when we have our denominator raised to the power of 1. So this is where our technique fails to work. So how do you solve such problems? So you can only solve such problems by using a simple method. You have to change what we have here. We have to change some variables. So that is, we have to change our x, we have to change our dx. We have to change our 2x plus 1 and change our dx. So we can say let u be equal to, all right, so this is a mistake. So this works when this denominator is raised to the power of 2, 3, but when it is raised to the power of 1, this is the method you're supposed to use. So that technique works for n greater than 1, strictly greater than 1. All right, so here we will have to say let u be equal to 2x plus 1. So we know that du is going to be equal to 2d dx. So du over 2 is going to be equal to d dx. All right, so if I change here, so this is going to be the integral of, now 2x plus 1 is u. Now our dx is du divided by 2. Now what do we have here? The 1 over 2 is a constant, so I can take it out of the integral sign. So I'm going to have half multiplied by the integral of 1 over u du. Now this is half. Now the integral of 1 over u is natural log of u in absolute values. So natural log of u in absolute values. Yeah. So now we resubstitute here. What is our u? Our u is 2x plus 1. So it is half natural log of, uh, that is 2x plus 1, right? Plus the constant of integration. So this is how you solve such a problem. When our n here, when our n is equal to 1, this is how you solve this problem. You don't use the technique for the one we employed in problem 2. So don't fall for such. Always try to know um, these things. We know how do I know that the integral cannot be 1 over 0? It's because 1 over 0 is defined and it is undefined. 1 divided by 0 is infinity, and that does not make sense. All right, so I'll see you guys next time.